All right, for example 3, we got some stuff to do. I have an x squared. And I'm going to figure out what I'm supposed to do with this thing. So I've got a vertical compression by a factor of 1/2. Okay, I've got to go left 4, and I've got to go down 2. So I'm going to make that happen to my x squared function, to my parabola. So anything vertical is going to happen to the function itself, and you're going to do what it says to do. So I need to do a vertical compression of 1/2 on my x squared. Okay, so notice that, I left some room in here just in case it's not just an x squared. So I took care of my 1/2. He's just going to be a coefficient on it. I'm going to go left 4. So remember, left, right, you go opposite. So instead of -4, I'm going to put +4. And now all of a sudden I understand why I use parentheses. So this says 1/2 times my parabola. Okay. And then I'm going to go down 2. So remember, up, down, you're just going to slap on the end and do what it says to do. So I'm going to say -2. So looking at that, I've got my vertical compression of 1/2. That's attached to the function itself, so it's attached to the x squared. Left, right is going to go inside with the x. Okay, anything horizontal is going to go inside with the x. Inside of parentheses, inside of a radical, inside of a denominator, whatever. It's going to go inside. And then it says go down 2 units. So up, down, you do what it says to do on the outside of the function. So that says grab this thing and drop it down 2. So let's do a 1/3. All right, so I have g of x is going to be my new function. It's going to be horizontally stretched by a factor of 3. So that's going to be something weird. It's going to go right 3, and then it's going to go up 7. So I've got 3 things that I've got to do to this thing. So I'm going to say g of x is going to be, I don't have a vertical translation, but I do have a horizontal translation. So that's going to be a little bit different. So just like when we moved left, I had to say +4. When I have a horizontal stretch, I'm going to flip this. So this is actually going to be a 1/3. So with the horizontals, you kind of sort of do opposite of what you think. So I have an x cubed, and what am I supposed to do? It's horizontally, so it's got to be inside with the x, but I'm going to move it, or I'm going to multiply it by 1/3. So I have 1/3, that's my horizontal stretch. I need to take that entire thing to the right 3, which means -3. So I'm going to say x minus 3, and that tells me that move it right 3 first, and then squish it, okay? It's a horizontal compression, okay? From there, what do I want to do? I want to go up 7 units. So anything up, down, you just slap on the end and do what it says to do, okay? So just to reiterate, I can now take that 1/3. So I've got a 1/3 x, and then 1/3 times -3 is -1 cubed. So notice that the inside needs to be in factored form, otherwise it's slightly confusing. If you look at it just this way, it says to go right 1. I don't want to go right 1. I want to go right 3. That's why I need to write it as 1/3 times that quantity. Okay? When you simplify it, it's okay to put it this way. But make sure as you're creating your equation to take your 1/3 times any horizontal movement. So let's try this again. I have an asthma attack is what I have. All right, so I've got g of x, and I would like to count how many things that I am doing. So I'm going to reflect this across the y-axis, and I'm going to vertically stretch it by a factor of 2. So notice that on a y-axis reflection, be very, very careful. If I'm going to reflect across y, y is my vertical axis, so that means I'm going to be flipping left, right, so that it affects your x's. So in order to flip left, right, I need to change the sign on x. And you're thinking, but wait, I can't have negatives underneath the radical. But what happens if I substitute in negative values for x? What happens if I substitute in a -1? What is the opposite of -1? It's +1. What is the opposite of -2? Okay, so you're flipping it across the y-axis. I want to vertically stretch it by a factor of 2. That affects my y values. So I'm going to slap a 2 in front of that thing, and I'm going to be done. That's as far as you can go. You cannot simplify that thing. So the last part that I want to do after I find a new cool marker is going to be, I'm going to take the cubed root of x, I'm going to reflect it across x, and I'm going to horizontally compress by 1/3. So I got to do two things to this. So I'm going to start with g of x equals the cubed root of x, okay? So if it's reflected across x, that means I'm going this way. So that's a vertical flip. So I'm going to slap that negative out front, okay? I am horizontally compressed by a factor of 1/3. Since it's going to be inside with the x, I have to do opposite of what I think. So flip that thing. That's going to be a 3/1. So this is now 3x. If I were shifting this left and right, I would put the shift in with an x. So like if it said to shift it to the left 1 unit, I would say +1 inside like that. Then I would distribute my 3. Okay. So it doesn't say that, so don't do it. So that is your answer for that question. So negative cubed root of 3x. So the last thing I want to do, I'm going to squish two of these in the same thing, is I want to find these equations. Okay. So first of all, we need to recognize what our parent function is. So I notice that this looks awfully similar to this, which is the square root of x. That is the square root of x. I need to know what's happened to him. So I do know that he's supposed to take off from the origin. But I'm recognizing that I went right 2, up 1. I went right 2, and I went up 1. So I'm going to handle my left-right stuff first, and then modify it as I go. So I have, we'll just say f of x. F of x equals the square root of x. That's what I would have started with. That's what this thing is. Okay. What did I do? I went up 1 unit. Okay, so let's take care of that first. That's easy. +1. Okay. What else did I do? I went to the right 2 units. So I need a -2 inside the radical with the variable x. So this tells me up 1, right 2. Okay, what else happened? I noticed that he got flipped. He should be shooting up and he's going down. So I need to flip this thing. Okay? I need to flip it. So I've done that. My last thing that I need to check for is if it's been stretched or compressed. So when I look for stretching and compression, what I do is I see if there's a 1-to-1 ratio. Okay, so let me grab some graph paper. Hang on. I am grabbing graph paper. What this would normally look like is I would have my coordinate plane and it would be coming off from 0. And then notice I would go up 1/1. Okay. And then from there it would take off. If I did that with a parabola, okay, it would look like this. So notice from the middle, I've got my up 1/1. Okay. If I did it with a cubed root, okay, I would have like that. So it would be an up 1/1. That's what I'm looking for, is this up 1/1 type thing. So when I come back over here and look at this, from what would have been the middle, I want to see if I've got an up 1/1. So if I move from here and then either up, down, and over. Well, I should be plotted here if I'm trying to find the graph. I'm trying to find the graph. So I'm going to go over 1, down 1. Well, that's not what happened. What did I do? I went down 2, right 1. So tell me the up, down number first. So that says I went down 2 over 1. And that should sound a little bit like slope to you. Okay, which it's not, but I'm just trying to give you something to think about. Okay, so that means that I have a vertical stretch. I made it go taller instead of just being from 1 to the next diagonal, just diagonal 1-to-1. I made it taller. So he's going to be a vertical stretch of 2. So let's try it again. Okay, I have What does this thing look like? This thing, I need to write with pencil. This thing looks like a cubic function. So what he looks like normally from all of your cool notes that we have provided for you is he would go up like this and down like that. So notice that it should have gone through -1, -1. Okay, but from the middle, I would go diagonally 1 unit and I would find my graph. So that's going to tell me about stretching and compressing. So what did I do first? He should have been here, but where is he? He went 1, 2, 1. So I went left 2, up 1. Okay, so I can do the up 1 first. Let's just do up 1. That's done. Did he flip? No, he didn't. He should be moving up and to the right. He's moving up and to the right, so he didn't flip. Okay, so I don't need any negatives anywhere. So I've got an x to the 3rd. Well, I also know that he went where? He went left 2 units. So that's going to be +2. Okay, so this says up 1. That says left 2. The next thing I need to look at is, did I stretch or compress? So I'm going to look for that diagonal 1 unit, and I don't find it. I need to go find him. So there he is right here. So how do I get from here to here? Tell me the vertical change first. I went 1, 2, 3 up over 1. So I went up 3 over 1, and I don't need the over 1. Okay, so that is the equation of this cubic function. So let's try 2 more. What does this one look like? This one looks like a 1 over x squared. 1 over x squared. Okay, I want to know, and I was saving it for last, but let's just look at this thing. Do you see your horizontal asymptote right there? Okay, so from the middle, can I move diagonally and find my graph by 1 unit? Yeah, I can. This has not been stretched or compressed. Okay, it also has not been flipped. So the only thing I've got to worry about is I need to move right 3 and down 3. So let's do the function first. So I've got a 1 over x squared. I'm going to drop this thing 3 units. So -3 on the end. I also need to move right 3 units. So in with the x, I'm going to put x minus 3. That tells me in the denominator of something being squared, okay, that means I went right 3 units. So let's look at this one. I'm going to find my asymptote first because that's going to help me decide if he got stretched or compressed. So here is my asymptote. So from the middle, I can go diagonally 1 unit and find my graph. He did not get stretched or compressed. So this is a 1 over x. This is a 1 over x. So I have f of x equals, well, what happened to him? Did he flip? No, he did not. You've got notes to look at on this. He didn't flip, but he did move right 3, up 2. So let's do the up 2 first. Up 2, okay? But he did move to the right 3 units. So I don't need an x to the first in my denominator. He didn't flip. He hasn't been stretched or compressed. And that is your answer.